Let's explore error handling in C programming. This presentation will cover the techniques for dealing with errors in C programs, ensuring robustness and reliability. One of the most common error handling techniques in C involves using return values to signal success or failure. Typically, functions return 0 or positive values when they succeed. However, upon failure, they return negative values or specific error codes. Consider this example of a file opening function. It attempts to open a file in read mode. If the file pointer is null, indicating that the file could not be opened, an error message is printed, and the function returns null, signaling failure. C provides a global variable called errno, which is set by system calls and library functions to indicate what went wrong. This errno variable is defined in the errno.h header file and is set to specific error code values. It is crucial to check errno immediately after a function call and reset it to 0 only when you need to as a programmer. Here's an example that demonstrates the use of errno. We attempt to open a non-existent file. If the file opening fails, we print the error code and a human-readable error message using the strerror function, which converts the errno value into a descriptive string. C provides several functions to help in reporting errors effectively. The function perror prints a descriptive error message to the standard error stream, based on the current value of errno. The function strerror returns a pointer to a string that describes the error code passed to it as an argument. Additionally, printf with str can be used to write formatted output to the standard error stream. In this example, we have a function that attempts to open a file. If the file cannot be opened, we use perr to print a message to str, and we also use printf along with strerror to print a formatted error message, providing more details about the error. Let's delve into some advanced error handling techniques and best practices in C. It is essential to check the return values of all critical functions to ensure that operations were successful. Handle errors at the appropriate level, providing meaningful error messages to aid in debugging and user understanding. Clean up resources in error paths to prevent memory leaks and ensure system stability. Log errors for debugging purposes to help trace and resolve issues. Consider error severity levels to prioritize and handle different types of errors appropriately. It is important to test error conditions explicitly to verify that error handling mechanisms work as expected. We will now see some advanced techniques like assert macro. Assert macro helps in verifying assumptions during development. Include assert h header file and use assert macro. Another technique is cleanup handlers. Use goto statement for structured cleanup. The other technique is custom error handling, which is used to create your own error system for complex applications. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.